Okay, another measurement is temperature measurement. Of course, temperature is defined by what? A measure of average energy of randomly moving molecules in a substance. That's definition of physics, right? Basically, you are measuring the thermal energy of the molecules. That's what it is. So the heat will transmit, okay, through molecules. So you will detect that transmitted heat. That's what you measure. So temperature is measured by allowing a thermometer. That's the device you will use to come to equilibrium. So when the thermometer measures temperature, it'll sense the thermal energy coming, and it'll be equilibrated with the temperature. Temperature can be measured in different units. Of course, Fahrenheit is one unit, and Celsius is another, and Kelvin is another unit. Among those, the most common international unit that we're going to use is, of course, degree in Celsius. Okay, and those units are interchangeable. These are the equations that you can use to change between Celsius and Fahrenheit. Okay. That's Fahrenheit minus 32 degrees times 0.556. Okay, if you're going to change the Fahrenheit into Celsius, it's Celsius times 1.8 plus 32. And between the Celsius and Kelvin, you can use this equation to change back and forth. And minus 273 is the difference in the Celsius and Kelvin. Okay, and there are different types of thermometers out there you can use. Among those, the most common and inexpensive thermometer types are liquid expansion thermometers. And we used to have the liquid expansion thermometers with mercury in it. But these days you don't see mercury liquid expansion thermometers anymore because mercury is very, very toxic and it's considered as an environmental hazard. So if that is broken, then you have to deal with the mercury exposure. So mercury thermometers are kind of removed from the lab most days, but instead we use alcohol-based liquid expansion thermometers. That's the common type. So the red liquid you can see from the glass thermometers, those are alcohol expansion thermometers. Okay, and if you have liquid expansion thermometer, depends on how they are made. There are three types that are available. Those are called immersion liquid expansion thermometer, or complete immersion, or total immersion thermometers. Depends on the type. When you measure the temperature of a liquid, you have to position the thermometer carefully. If it's a complete immersion thermometer, the entire thermometer should be immersed under the liquid. Okay. And then if it's a partial immersion, yeah, you can just stick a little bit of your thermometer into the liquid. If it's a total immersion, at least the alcohol surface should be under the liquid that you are trying to measure the temperature out of. Okay, so those three different types of the thermometers depends on what you have. You have to place your thermometer accordingly. Okay. There are pros and cons on the liquid expansion thermometers. They are, cheap, so you can easily buy, but they have a wide tolerance, 1 to 5 degrees in difference. Okay, and they are also made with glass, so they are easily breakable. And sometimes separation within liquid inside of the glass happens. So if that happens, it's hard to use it. So that may be the end of that usage of that thermometer. So it's cheap, but there are some cons on using this thermometer, liquid expansion type. And then there are different types of thermometers. Again, bimetallic expansion thermometer, which is not that accurate. Okay, two different metals are put together using different expansion type, and you can measure the thermometer. Another type is resistance thermometer, which is more accurate. So using the electric resistance that changes based on temperature, you can read the temperature. And thermostat uses semiconductor that shows decrease in resistance with the temperature change. And thermocouples, again, use two different metals that are joined together to detect the temperature. And verification of your performance of lab thermometer is important. There's a way to do that. Your textbook explains that process. And then we're going to move into the pH measurement. So one of the another commonly happening measurements in the lab is a pH measurement, because you will be making a bunch of solutions that have certain pH capacity, like buffers, and you have to measure the pH value of your solution. So how do you do that, and what does it mean by it has certain pH? Okay, so pH is basically measuring that what amount of hydrogen ions present in your solution. That's what pH is. If it's a pH 7, you have about 1 times 10 to the negative 7 moles of hydrogen ion per 1 liter of liquid. Okay, so make sure it's a negative 7. So it's a negative log of the concentration, hydrogen ion concentration. That's what pH value is. Okay, and acid solutions will have more hydrogen ions because this value will decrease, negative value will decrease, and the base will have a higher number because you will have much less amount of hydrogen ions. So the log of 1 times 10 to the negative 7 is negative 7, and you make that absolute number as a 7 is the pH value. So what do you use for your pH measurement? Of course, you're going to use a pH meter, right? Or you can use something like pH indicator. Different kinds are out there, but the most common measuring device is a pH meter. So that comes with the pH electrode. Okay, so electrode is very sensitive in measuring the pH value, and basically what you're measuring is actually electrical potential, the voltage that's floating in the solution, not the hydrogen ion itself. So that's what you'll be measuring. Okay, so typically the electrode comes with a pH meter, has an electrolyte inside of its container. So you need to make sure that you have enough electrolyte in your pH meter electrode. When you perform a pH measurement, every time you use a pH meter, you have to calibrate your pH meter using at least 2 different standards. And one of those 2 standards should be a neutral pH solution. That is pH at 7. So you always start out with the pH 7. You're going to calibrate that pH 7 as a 0 millivolt, and then you use different pH, maybe pH 10 or pH 4 from there, and which will give you another set point of in millivolt. By connecting those 2 points, you will see the conversion of millivoltage to 1 pH value. Okay, so if it's your pH meter is in good condition, that the slope of the 2-point calibration should be higher than about 97%, which is about minus 57.4 millivolt per every pH change. Okay. When you perform a pH calibration, of course, the condition of your pH meter is important. So your electrode should have enough electrolytes filled in there. You should not have any dried out electrolyte solution and everything. Another important thing is the standard buffer themselves. They should be a fresh standard buffer that have the correct pH values. So good standard buffer is really important. And then temperature also affects the pH value determination as well. So in other measurement, you saw the effect of temperature. The same case, temperature also affects. So because of that, normally many pH meters come with the auto temperature compensation probe. So when you take a pH measurement, not only you place the electrode in your solution, you also have another probe looking like electrode, but it's made with metal that should go into the solution as well. So your pH meter will be detecting the temperature of the solution and automatically compensating the difference in the pH value based on the temperature difference. Okay. pH measurement step, of course, you have to turn on the pH meter and warm it up, and then check the electrolyte level in your electrode, make sure it has enough of it, and clean up if it needs to be cleaned up, and calibrate using 2 standard buffers, pH 7 first and then acidic or basic. It doesn't matter whichever you like, you use, and then place the electrode in the sample solution and measure it. That's how you do it. And another important thing is when you remove your pH electrode from one standard solution to another, you have to wash your electrode using deionized water, a squat bottle, and after you rinse it and wash it, you have to dry your electrode by damping it or blood drying it. Blood drying means you don't have to wipe it up. Instead, you just dab your electrode with the Kim wipe. You do that because if you wipe it up, you may create some static electricity. So you don't want to affect the pH electrode with the static electricity. So that's why you don't want to wipe up your electrode. Instead, you do the blood dry. That's very important. Okay. Okay, finally, the conductivity is the last measurement we'll talk about. So conductivity is a measurement of a total ion concentration in a solution. So when you make a solution, not only the pH value is important, also the amount of salt is important. So when you do a chromatography run, there is a binding buffer at certain salt solution, and then there's a washing buffer with more salt, and then maybe the elution buffer will have a higher solution salt concentration content. So the change of the salt concentration matters in your operation. Then how do you measure that salt concentration change? You use a conductivity measurement. Okay, so at the higher conductivity, you will see more salt present there. So the unit that is used in measurement, conductivity measurement, is a Siemens per centimeter. Okay, so take a look at your textbook to understand what it means and about measuring conductivity. Okay, that's the last slide. So you have a homework assignment. Okay, it's the same website, the NC Bio Network website. If you go into these two websites, you will see two e-learning modules. Okay, one is on the pipette, and the other one is on the glassware accuracy, the volumetric measurement. Okay, I want you to complete both of them, and I will give you 10 points for each certificate. So you will have to upload those certificates at the end in your course shell. Okay.